Okay, so I decided to show you all of these codes, and I wrote up these codes for you, and I wanted to demonstrate them so that you have a better understanding of how these codes work. So firstly, we have the linear search algorithm. The idea is to search for something in a list. Let's make a list here. So I'm making a list V, which goes from -5 to 5. So this is the list that I have. And let's say I want to find x equals 3 in this list, which is I want to find the location of element x equals to 3 in this list. And so let's see how this would work in the linear search algorithm. Want to find x in V. Okay, so firstly I have this entire list, and according to my algorithm my x is equals to 3, and the I that I'm looking, and I has been set to 1. So this was the first line of the code. Let's follow this algorithm. The code enters this loop. I was less than and equals to n. N over here was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n was 11. I was obviously less than and equals to 11, and x was not equals to ai. AI in this case is basically the ith element, that is the second element of this list. So it's not equals to this element, therefore it enters this while loop. And it keeps on doing that. It keeps on increasing the value of I until it either I is less than or equals to n, and x is not equals to I. One of them is violated. So we keep on going. X is 3, I is 5, 6, 7. And we see that when I reaches 9, then we have the condition that ai, that is the ninth element, 1, 2, 3, 4, 5, 6, 7, 8, ninth element of the list was equals to my x, and that's when this while loop stopped and my location was set to 9. And so that's how linear search works. Let's try the same for binary search. Bin search x and v. So what does the binary search algorithm do? Let's go to the binary search algorithm. Binary search starts I as 1, which is the left endpoint of the search interval, and j is 11 to be this right interval. So initially this entire thing is my search interval. The entire list is my search interval. And then I check this I is less than j condition, while loop. This is obviously not true right now. So I get m set to be 6 because I was 1, j was 11. And now we check this condition. If x is greater than am, x is 3, and the mth element of my list was 0, 3 is greater than 0, that condition holds, then I will be set to m plus 1. I was 1, I will be set to m plus 1, which is 7, and we see that I has now been changed to 7. This code was executed, j was left as 11, and now my search interval is different. My search interval starts from the 7th element and ends at the 11th element. And we repeat this while I is less than j. This condition is still true. So again, m gets a different value based on the values of I and j. We check this condition again. Is x greater than am? X is 3 and vm is 3. That condition is not true. Therefore, this condition will be executed. That means j will be changed now. So I is the same, j has been changed to the value of m, and we repeat this. We see that the search interval was smaller. We get a new value of m, we get a new value of x, we check what the vm was. Again, we check whether x was greater than am. 3 was greater than 2, yes. So now I will change. I changed, so my search interval has been reduced to just one element. And when this happens, this while I less than j is no longer true, and I will break out of this loop. Now we will just check whether x was the same as ai. That's true, then location was set to be 9, and that's how binary search works. So you saw at every step the search interval became smaller and smaller. It got broken down into two parts, and we only looked at the part that contained the value that we were looking for. And so there it is. Of course, if we run bin search for a value that doesn't even exist in my list, then we'll obviously should expect the output to be 0 because the element does not exist in this list. And so we check that. The search interval gets smaller, the search interval gets even smaller, and the search interval gets even smaller, and at the end it checks whether x was equals to ai. That's not true, of course, so the location was set to be 0. And that's how binary search and linear search work.